welcome everyone to the latest edition of the Reimagined Mobility Podcast series. I'm here with Nick Tumilowicz from an area that we haven't really talked much about in the mobility space, but certainly very critical, which is the energy space. So Nick will really highlight what's going on in that space and how is that helping us as we talk mobility in the broader sense, reimagine it as we go forward. So Nick, thank you so much for joining us. Maybe to start out with, give a little bit of your background, and then by all means, please talk what you and your company are doing today, and then we jump in together and reimagine mobility.
Sounds good. Well, appreciate you having me, Stefan, and team at the AVL group. My name is Nick Tumilowicz, Director of Products, focused on distributed energy management. And so this is within the Outcomes group at Itron. Today, we have 8,000 customers. We have 200 million endpoints communicating to back-end systems where we provide analytics to really help facilitate this whole energy transition that we're all undergoing and discussing in the energy business on a daily basis. Now, my role in the last 25 years within that context is how do we leverage all of this investment that's been deployed, all the metrology, all the telemetry communicating to enable us as consumers to be able to adopt whatever it is that we want to adopt, to be able to participate and to help the grid be a good grid citizen, as opposed to doing what we have been doing 20, 30 years ago, is kind of fighting the grid. So how do we become a part, work together, design and develop programs, so that way, Stefan, you can install however much solar you'd like. I can purchase as many EVs as I would like, and maybe things like battery energy storage and thermostats and hot water heaters and pool pumps can all be a part of these resources that Itron is really helping provide access to incentivize and motivate customers to help utilities do things bigger, better, and more cost effectively over time.
Interesting. So really then we can also say you're really heavily into the decarbonization of the energy space, right? Or the energy solution, energy creation, et cetera. And then with your company's view on how do we really connect to the grid, connect all the meters, get all this whole ecosystem sort of brought together. What is it then as it relates to the future of mobility, or again, reimagine mobility? What do you see happening next, right? I mean, we see all sorts of different things, from generating wind energy, generating clean hydrogen to use that for energy generation, not only in vehicles, but in backup generators for critical IT infrastructure. You mentioned everything goes to the cloud, data is analyzed, so you're using AI, so you need more horsepower there, more power again. How is it that you guys see the future of mobility playing out in your space?
Sure, yeah. So, I mean, mobility has been through its journey over the past, a couple hundred years. It's gone through some pretty significant challenges and evolutions, and it always takes some time for society to really be able to accommodate, from horse and buggy to our first foray in the early 1900s with electric transportation, which then turned to combustion, which now has another go-round of electric transportation. And everybody, these days has an opinion about where that's going. Is it going to be the hockey stick that we would expect? But what we see in the industry, if we just kind of widen our lens a bit, is that these things always take time to get from the horse and buggy to the combustion engine, to really have confidence in the 12-volt lead-acid battery that was going to be able to need to get that combustion engine to work. That really took time. And now we see, since, whatever it's been, the past 25 years, as long as I've been in this energy business, is transportation starting to really mature. That whole technology readiness level was very early pre-commercial days 25 years ago. And now we start to see, as you can tell, every auto OEM is really participating. So the future, I think, that we see is that there is no silver bullet. There's going to be a varied amount of different types of technologies. Hydrogen is certainly a component there. Plug-in hybrid electric vehicles that still uses combustion and battery technology. and then pure battery electric vehicles. That's just on the light duty, medium duty, and heavy duty type of vehicles we're talking about today. But we don't want to forget about how Europe, as an example, has really electrified their locomotive, trains. And we're doing a similar thing, or making an attempt in North America to do something very similar. The one thing that's clear is that whether it's mobility or it's the homes that we're all communicating from, everything is really starting to shift and pivot towards electrification. So it could be, my wife would like to remove the gas dryer and transition that to a 240 volt type of device, or replacing my old gas stove with induction because of air quality considerations. And so what that all does, when we see all this electrification coming into play, coupled with the driver of decarbonization, and there are some utilities that we're working with today that actually have only 6 years to go to not get to net zero across their millions of end users, but they have to get to 100% clean and renewable energy. And Itron is really trying to help say, okay, from a generation perspective, all the way down to transmission, distribution, and to consumption at the edge, Itron is really trying to help solve the problem at the root to say, I will manage my EV and will do it in an autonomous way in order to save me money as a consumer and to help overall reduce the costs and the increase operation efficiencies at the utility distribution side.
Interesting. So you made an interesting point when we change systems in anything, right? Is that we move from landlines to cell phones. We move from gasoline-powered vehicles to electric vehicles. We want it now more than ever, probably in the last 100 or 200 years of transportation. We want it faster and faster, right? So, and you just mentioned you guys are trying to help make that transition happen, trying to educate not only the mobility consumers or the power consumers, but also those that generate and provide the power on how to do this. So is one then thing really teaching the public, teaching all the consumers of not only mobility, but in general of power, so to speak, of energy, that it just takes a little bit longer, or would I need to be more patient as we kind of become more and more of a less patient society, I think, globally? Or are there still more technical hurdles involved, similar to what we have with EVs, with batteries challenges, range challenges, infrastructure challenges, etc.? It would be interesting to see your perspective on that.
Yeah, I think there's a couple things in there. One thing is that, yes, it's always good to educate the consumer base, especially since we're moving so fast. I have a 20-year-old and I have a 5-year-old, and they're both on different journeys in terms of what they were faced with in their technology adoption. And that's only a 15-year difference. So we're starting to see this acceleration and compression on how consumers need to get on board and move with new technology, whether it's cloud, type of integrations, or, telecommunications, like you said. So that's one piece, is the education, without a doubt. Frankly, within my business, within Itron, within the electric industry, that is easily 30% of the daily job, is to educate, is to kind of set the expectations, level the playing field. And it also is really critical with our customers, the utilities and cities, is to get them to clearly understand. But what I'd push back on a little bit is that we don't have much time. There are utilities out there, as I mentioned, they have 6 years, to get to these aggressive 2030 goals, to be able to accommodate consumers like tomorrow. And that's really where Itron, and I know our partners and some other participants in the industry, are trying to solve for those problems this year and next year, based on all the work that we've deployed over the past, decade or two. And that's where I think it's important to kind of share one of the things that's so important to us, that we're getting a lot of good feedback and that new adoption, is that old metering technology that used to be out there, you could call it AMI 1.0. It started with just meter reading to operationalize efficiencies. And then it moved towards kind of smart meters. And we went through that in the late 2000s, 2008 era. And now we're moving to this next advanced metering, which is smarter than the smart meters that we deployed, which has literally an embedded Linux server DER gateway inside of it. So that's what we used to do 20 plus years ago, is install little computers on every system, whether it's a solar rooftop or it's battery energy storage or it's electric vehicles. There's no need to do that anymore because of all this technology advancement and compression that now fits within your fingertips, dropped into a meter that allows you to autonomously use those energy resources on the customer side, to be very aware of its limitations at that transformer that might be sitting outside your window on a pull top or in a green box in your driveway. And that's really where we're focused, is to say, in real time, within sub-seconds, what is the condition of that transformer? And you and I, before this call is over, we could all, purchase 4 EVs, and that transformer would be compromised if we plugged it all in at the same time. So the goal is to be proactive, send that actionable data to the right people, like grid operators, and allow customers to participate. And one small example of that would be, we can simply say, why don't we just within cycles change and throttle how many amps that device, this electric vehicle, is charging it. 60 amps is what it's set to by default, but because the air conditioner just kicked in, it's 116 outside, let's throttle that down to 10 until that condition changes, and then you can be on your way and take your kid to school or whatever you need to do.
Okay. So you touched a little bit on my next topic, Nick, is the pathway, right? How do we get to a reliable grid, or a more reliable grid? Some states have it much more reliable than others. Some areas are more than others. What is the pathway to not only renewable energy, but also, again, this very much smart or maybe AI-based metering that you just talked about? My meter is literally behind me on the other side, on the outside, and once a month there's still a guy coming, reading it, and walking away again, right? So maybe I'm still stuck in the 1980s, I don't know. But what is some of the pathways to grid reliability, to really get to the vision that you just shared, where this metering is not just a metering anymore, but really helps us manage the entire grid, with maybe not necessarily the need for many more power plants, but just much more smart management of the resources we have. Share a little bit about that pathway and the pieces that you guys are looking at there.
Sure. Yeah, I think to oversimplify, we kind of view this as the good, better, and best type of scenario. And I've referenced a couple times this best scenario because we want to really share what we're approaching about a score of utilities now that have now decided to move towards and adopt this new distributed intelligence technology. We call it grid edge type of intelligence. And while maybe 20 out of 1,300 utilities, big utilities in the United States, of the total, the 3,000 of the munis and the co-ops that are out there, they're electing to go this route because they really see the business case, they see the value. But you do need that next generation smart meter to be able to make that happen. You need a pretty solid pipe and throughput on all of the telecommunications that communicates with all those meters. And you need to be able to have those meters communicate directly to those devices. And so we are doing that today for the kind of the more progressive, advanced utilities and cities that need to make progress quickly. But one click down from that, we can't leave, all of the other utilities and cities behind, right? So we have, better scenarios which say, well, maybe you have stuff on that, maybe your AMR that is sitting behind you, which is kind of 80s. But maybe they have the late 90s or early 2000s version of the initial smart meters that at least give you the opportunity to not work within sub-seconds, but within minutes. And that could be a better solution than what we have today. That would help your utility. That might reduce your costs. And then, of course, we have utilities that are a little bit further out that maybe don't have the aggressive decarbonization goals, or if they do, it's a 2045, 2050 timeline. And we're providing good solutions to them to stitch all that data that's coming to a consolidated backend to help them make, maybe minute plus decisions. So this is a pathway that we're offering. We don't want to leave anybody behind. We want to help everybody, but sometimes investment cycles, regulatory cycles suggest you have to offer this good, better, best type of approach.
Interesting. So, Nick, you talked a couple of times now, I think it can be summarized in this grid edge intelligence, right, that you're talking about. And my interest is, and I think a lot of the listeners and viewers maybe as well, is all sounds good and it makes total sense, but what are the challenges getting there? You mentioned, again, more EVs, more is getting electric, more has to be sustainable power generation or green energy, if we call it that for a moment. What are the challenges to really implement this edge intelligence you're talking about, that sustainability to not necessarily having to build all more of these power stations that we're already struggling in this country and certainly in Europe as well to create, but live with what we have, but live smarter? What are the challenges to get there?
Yeah. So we talked about North America. We talked about Europe a couple of times now. Maybe I want to focus on what we characterize as a continent that is like a postcard of the future with renewables, Australia. Hawaii also fits into that. 2 islands, one slightly larger than the other. But Australia, just to put a fine point on it, when I first visited back in 2015 to help with renewables and do the deployments, all the utilities came to me and said, can you please slow down? Because all of our citizens in Australia really appreciate energy independence and power of choice and being able to purchase and adopt and save however they would like. They did a fabulous job of enabling that momentum for DER adoption, specifically with photovoltaics, solar electric. So you have all these rooftops, and now there are certain metropolitan areas and certain circuits that are now 60% PV penetration. And when you get to saturation points like this, you have very limited ability to add any more PV. Your PV hosting capacity now is really compromised. This is a significant challenge, and it's manifested in retirees that are home, in the middle of the day, calling up the operations center, yelling at their utilities, saying, why are my lights flickering between 10 a.m. and 2 p.m. every day? Well, you have, the technical explanation is you have way too much power being sent back through the transformer, and it's trying to figure out where to go and what to do with itself. It's not this days of yore, the old Australian, brown coal plants pushing it just to your refrigerator. So that was several years ago, and we're still really trying to focus on solutions to help enable more solar to be deployed on top of how painful, that already is. To deploy technologies like battery energy storage. Electric vehicles will be coming soon for that particular region. And then you can start getting all these to work in concert with each other and to really limit the customer dissatisfaction, which typically happens in early markets where you let everybody adopt, and then you say, I'm going to turn off your solar for a little bit. You don't mind, do you? And so, well, that actually affects my payback, my return on investment, my IRR. That's not really comfortable with that. Thank you very much. Can you please come up with other, advanced solutions? And that's what we're trying to do here.
Interesting. So yeah, my dad lives in Europe. He has solar panels as well. And every time I'm there or visiting or talk to him, he always wants to show me his app on how much energy he has generated that goes into the battery and how much he has sold back to the local municipality. And it definitely is, I think, also an incentivator to some degree, right, to do this. But let's maybe take it a step further with what you just explained with Australia, which is very interesting. So if you take globally where you guys operate, which countries are really leading to what you just explained to our listener and viewers over the last 20 minutes that you guys are doing, or where this smart grid or edge grid intelligence can help us and is going, and what the future looks like? It also then impacts, obviously, the future of mobility or how we reimagine it. What are some leading countries? Again, it sounds like you mentioned here Australia would be in part of that. Right. Who else is there? And then maybe at the end, for our maybe more U.S.-based listeners, where does the U.S. stand with all this?
Sure. Yeah. Maybe I'll start with, we talked about Australia and the challenges that they're experiencing. And I think an important quick note is that for the listeners and what you hear on mainstream media, my mother will call me up and say, wow, 30% PV penetration in the continent or the country of Australia. But you have to be very careful with that message, because that doesn't paint a very clear picture of the problem. The problem is what I had mentioned a minute ago. It's 60% PV penetration on a particular circuit at that particular feeder, compromising that particular neighborhood that you live in. So we have to be careful of these gross, broad brushstroke generalizations. A very similar thing happens in the US, where they say, oh my gosh, all these EVs are coming on board, and how can this country in the United States accommodate all of these EVs? And that might be a little bit inverse, is to say, well, we have plenty of space to accommodate all of this new load. We did it back in the 1950s with a thing called the air conditioner. And that started in New York City in 1910s, 1920s, and then it became commercialized and it scaled. And then, we have low cost, and then everybody in the Southeast United States adopted. And what utilities distribution system operators had to do was to quickly figure out, how do we respond to this? And at that time, the solution was transmission distribution upgrades. Take out the old, very skinny copper aluminum conductor and upsize that to accommodate that more capacity, so that way they could have the reliability and the choice that they wanted. Because that was amazing. The air conditioners at the time living in the South. Now, fast forward, whatever it is, 75 years later, and now we have this new load, which is bigger than a 5 kilowatt point load. It could be easily, whatever that might be. It could be 12 amps easily on a level 2 charger in your garage, a new 60 amp circuit, and you might have multiple in your garage. So it is okay to solve that problem the old way with distribution upgrades, transformer upgrades, what have you, reconductoring. But there's also other tools in the chest that we have to provide what we call like automated or autonomous load management. So that way utilities, like they do in New York City, don't have to replace that 20-year-old 100 kVA transformer. They can let those school buses that are being replaced at a pretty high velocity right now from combustion to electric. And it's just a matter of being smart about it. You don't have to charge all of the 20 buses simultaneously to get the kids to school. Rather, you can just stagger these. And while you do that, always be grid aware to recognize the capacity of that transformer that's providing the energy and to protect it. And if something gets a little bit and that headroom starts to go to zero and you start to really stress the transformer, you can send a command and have everything wind down. So now to your question about countries that, so there are different pockets within US, and they typically seem to flank either the left or the right coast, with a lot of metropolitan areas and kind of progressive adoption policies. But there's also countries in Europe like Spain, UK, France, to name a few, that are really starting to adopt large point loads with fleets. And this could be 10, 20 megawatt point loads that these utilities have, these DSOs, distribution system operators, have to accommodate. So those are some pretty progressive areas that we're focused on.
Great. This has been really interesting, and certainly, as I think we mentioned at the beginning, right, very much related to how we reimagine mobility, because the future of mobility, independent of what it is that makes the vehicle move forward one way or the other, energy distribution system and certainly electrification is a critical part of this. So thank you very much, Nick. And maybe on the last question, not related to your field of expertise, but what is the next car you're going to buy and why?
Well, I have to share that I have moved many years ago, decade plus ago, from combustion to plug-in hybrid. And that's been really great, especially to accommodate any of the anxieties of my family members on, going up to the mountains here in the Colorado Rockies and being able to come back down. And it's good, but it's a complicated vehicle. I have to, my combustion engine has to dance merrily with my battery energy storage DC drivetrain. And overall, these technologies are pretty robust, and it's been fascinating over the past decade to see them move together. But to answer your question, I think moving to pure battery electric vehicle, because of its efficiencies, because of its reduced total cost of operations and ownership, certainly becomes interesting. And most important, when I drop my kid off at school and it's 20 degrees Fahrenheit out in Denver, my combustion engine doesn't turn on frustratingly like I don't want it to, and I blow smoke, in some kid's face somewhere. So that's why I'm going BEV.
All right. Very good. Thank you so much, Nick, for your time and for your insight in this very interesting space that hopefully many of our listeners will really benefit from learning what's just outside of traditional mobility, that we think something that's moving to something that really helps move